Hello, Leon. It's your Zayde, Mason. I'm here today to read you General Relativity for Babies. This is for you. This is a ball. It's a blue ball, but it's a ball. This ball has mass. It exists and takes up space. This ball has more mass, and this ball has less mass. More mass, less mass. This is a flat space. It's flat. Flat. Just not curved. But when there's mass on it, mass warps the space, becomes curved around the mass. If there's less mass, there's less warp. See how it curves? Curves even more with more mass. Curves less with less mass. More mass, even more mass, more warp. This is a small particle. That's the mass. This is the flat space. This is curved because it has mass. And this is a particle. Little red dot is a particle. The particle is trying to move from here to here. See that? But it can't. See? Look at that. See how it's moving? It wants to go that way, but it can't. And that's because it has to follow the shortest path through curved space. And there is a mass here, you just can't see it. And the particle is trying to go that way, but it ends up getting pushed around because it has to go through warped space. And the space is warped because there's mass there. Here we have a spinning ball. It's spinning. You've seen balls spin. That spinning ball drags space. Ooh. That's even more interesting. See how space curves in a weird way around it when it spins? And space drags the mass. So not only does it curve that way, even though it was trying to go in one direction, and then it goes even further, and then the spinning mass causes it to keep going in a spiral. And we'll teach you about spirals someday. This is flat space from a different angle, sort of what we call bird's eye view. And this is what it looks like when there's a mass in it. See mass warp space from the other angle. So this is what flat space looks like that. See how they look similar? And this is what it looks like when it's curved. If you shrink a large mass down enough, it'll become a black hole. Also what we know as a singularity, mathematically speaking. Or in physics. A black hole is a very large amount of mass in a very small area. Think the entire mass of our sun in the size of, I don't know, a basketball. It's a lot of mass in a small area. A black hole has so much mass that not even light can escape its warp. See, it's black. It's because no light is getting out. Once light goes in, it can't come back out. Well, there are exceptions, but we're not going to talk about that here. The center of the black hole is called a singularity, as I just mentioned. Guess I hadn't read far enough. Two black holes can spin around each other, and we've seen that many times in astrophysics. And we've talked about astrophysics a little before. They send ripples through space called gravitational waves. And there is a gravitational wave detector near your Zayde and Grandma's house in Southern California, up on the mountain on Mount Wilson. It's a gravitational wave detector. And I'll teach you about how that works someday. These waves stretch and squish space throughout the universe. And we have the ability to detect it when it's stretched and squished. Anyway, that is general relativity. Now you know general relativity for babies. And this was for you. Well, I hope you enjoyed that, Leon, and I love you very much, and I will read you another book soon, okay? Bye.